Hi everyone, this is Module 3. The title is Measures of Association, although I do think it actually makes more sense to call it Measures of Comparison. This is what your textbook uses, so we'll say association. But in any matter, we're going to talk today about 3 measures or ways to compare disease risk, and these are risk ratios, odds ratios, and attributable risk. So all of these techniques, these measures of association, are designed to help us know if a certain risk factor actually increases risk. So does smoking really increase the risk for lung cancer? Does physical activity really increase the risk for cardiovascular disease? And so on and so forth. So risk factors are anything that may cause disease. Another term that could be used is an exposure, anything that you're exposed to, or a cause as opposed to an effect. So an exposure or a risk factor possibly may, but may not, increase the risk of an outcome. Usually we're talking about disease, but it can be other things. For instance, here's some examples. Does folate deficiency increase risk of neural tube defects? These are defects, birth defects. And there was a question about do certain mineral deficiencies, specifically folate, might it be related? Does physical activity decrease risk of breast cancer? Does playing the piano increase math skills? All of these are examples of questions where there's an exposure and an outcome. So the exposures would be folate deficiency, physical activity, and playing piano. The outcomes would be neural tube defects, breast cancer, and math skills. So really the question we want to know is the exposure related to the outcome, yes or no. And so in order to do that, we have to have data from 2 groups, the exposed and the unexposed. So we would need to have, with the folate example, we would need to study people who have a folate deficiency, those would be exposed, and people who don't. We would need to know about breast cancer in people who are physically active compared to people who are not. We would need to know about math skills in people who play the piano and people who do not. We cannot answer these questions without some comparison. We need to compare the outcome in the exposed group and the unexposed. So when we do that, we can quantify mathematically an association. Is there an association between the exposure and the outcome? Comparison is really what epidemiology boils down to. We compare the risk in 2, or it could be more groups, but usually it's 2, and that allows us to evaluate risk. Is this risk factor really risky? Does smoking really add to the risk? Does physical activity really reduce the risk? Does playing the piano really make you better at math? And so on and so forth. So again, the 3 measures we're going to talk about: risk difference, risk ratio, and odds ratio. I also want to remind you that the textbook is a very helpful tool here. All of the vast majority of the tables that you're going to see are from the text, and they're explained very well there. So don't forget to use that tool for your reference. This is called a 2x2 table. You can see that there are 2 risk factors, and 2, it's called disease status here. It's outcome, essentially. Exposure is the risk factor, outcome is the disease status. So there's really 4 columns, and then you can add them up. So if a risk factor is present or absent, that can be represented here, and if the disease status is present or absent, that can be here. So if we do the folate deficiency and neural tube defects example, the risk factor, if someone was deficient in folate, they would be in this row. and then if they had a neural tube defect, it would go here. If they did not, go here. And then if in those who did not have the deficiency, but they do have neural tube defects, that would go here. And then those without neural tube defects and without folate deficiency would go here. So if there were 10 people with the defect and the deficiency, the number 10 would go here. There might be 5 people in this group, 20 in this group, and 25 in this group. And then you could calculate the total number of individuals with the risk factor present. That would be A plus B. So whatever was in box A added to whatever was in box B, and so on and so forth. So here I want to show you where these numbers would come from. So let's go back to the smoking example. If smoking is our risk factor, if that risk factor is present, that would be the smoker. If it's absent, that would be the non-smoker. And say our disease is lung cancer, then if the disease is present, that would be those with lung cancer, and if it's absent, that would be those who do not have lung cancer. And so, again, you would put the numbers of people who fall into this category. So if you had 500 participants in your study, you would put the number of those 500 who are smokers and have lung cancer here in A. You'd put the number of those 500 who are smokers but don't have cancer here in B, and so on. Calculate the incidence rate of disease with a prospective cohort. Alright, there's another type of study called a case control study. It's pretty similar, but it's a little bit different because it's not prospective. You don't watch people over time. What you do is you take what we call cases and compare them to controls. So this would be like if you found 100 people who have lung cancer and you found 100 people who do not have, and then you ask them, are you a smoker or not? So it compares things that they did in the past. The risk factor it's asking about, did you do this in the past? Now that you have the disease, did you do X, Y, or Z? That's a case control study. So we can't study, do you develop the disease in a case control study because they already have the disease. So it does look a little bit different. Remember, instead of the do you develop an outcome or not, it's cases versus controls. Do you actually have the disease or do you not? And then we can't calculate incidence rate, but we can calculate what's called the proportion exposed. So it's the proportion of those who have a disease or who do not out of those actually exposed to the risk factor. So it's A over A plus C for the cases and B over B plus D for the controls. Okay, so we still haven't gotten to the point of these tables. It's really to calculate these 3 measures of comparison. Okay, without the table, it's not as clear-cut how to calculate these. These make it nice and simple. So first let's talk about the risk difference. This is probably the most straightforward of the 3. It's just the difference between 2 risks. Okay, so it's abbreviated RD, and it can be calculated risk in exposed group minus risk in unexposed. So for instance, you would say the risk of some outcome, any outcome, is a certain percentage in the exposed and a certain percentage in the unexposed. For instance, say the risk of lung cancer is 20% in heavy smokers and 1% in never smokers. Well, then you could calculate the risk difference to be 20% minus 1%, so the risk difference is 19%. That's the difference in those exposed versus those never exposed. Or the risk of appendicitis in popcorn eaters is 4% and 4% in non-popcorn eaters. So there is a risk difference of 0. In that instance, 4 minus 4, that means there's no no association of popcorn and appendicitis. Okay, so how to calculate this? Using your 2x2 table, you can see from this 2x2 table that this is a prospective cohort study because you have the incidence rate there, and then do they develop or not develop the disease. And you have actual numbers for A, B, C, and D, so that's the number of people in the study. So take a look at how many people you think were in this study. If you said 10,000, that would be correct. We can tell because if you could either add A plus B plus C plus D, or you could add 500 plus 9,500. You get 10,000 total people. Of those 10,000, 400 were sedentary and develop coronary heart disease. We know that from the title of the table that the outcome they're looking at is coronary heart disease. 100 people were active but developed coronary heart disease. 5,600 people were sedentary but don't get the disease, and 3,900 were active but don't get the disease. So the incidence rates have been calculated, 6.7% in those who are sedentary and 2.5% in those who are active. So you can calculate the risk difference as A over A plus B minus C over C plus D. And if you did that, you would get 400 divided by 400 plus 5,600 minus 100 over 100 plus 3,900, or it's broken down for you further on the slide, 400 over 6,000 minus 100 over 4,000. And that comes out to 0.067 minus 0.025, or 6.7% minus 2.5%, which of course is the incidence rates, the difference in the incidence rates. So 6.7 minus 2.5 is a risk difference of 4.2%. So what this means is that those who are active lower their risk of coronary heart disease by 4.2%. Remember that the incidence rate is a measure of risk, so therefore the risk difference is just the difference in the incidence rates. Sometimes the risk difference is also known as attributable risk. It's the risk you can attribute or assign to a certain risk factor. So here's a kind of a silly example, but I hope it will help you. People who eat hot dogs have a 10% risk of toe cancer, while people who do not eat hot dogs have a 4% risk of toe cancer. So what is the risk difference? 6%, 10 minus 4. Very simple to calculate that. But what does that actually mean? It means that you can attribute or assign 6% of the risk of toe cancer to eating hot dogs. Another way to think of that is if no one ate hot dogs, 6% of toe cancer cases are eliminated. So there would still be toe cancer, but 6% of the cases wouldn't happen. Another way to think about it is that 94% of the risk of toe cancer comes from something besides eating hot dogs. Only 6% of the risk of toe cancer is from hot dogs, so 94% is from something else. That leaves it up to you to decide, should you continue to eat hot dogs or not? Do you think the risk is high enough that it's not a good idea, or are you willing to accept that risk? Alright, let's move on and talk about relative risk. This is sometimes called the risk ratio. Both are conveniently abbreviated RR. I'm going to call it relative risk. But this is simply the ratio of risk in an exposed group to the risk in the unexposed group. So if the risk ratio is 1, that means the risk in the two groups is the same. Remember, epidemiology works in comparison. So we're comparing risk in exposed to risk in unexposed. Say a risk ratio is 2.0, that means that you have 2 times the risk of disease in the exposed. If the risk ratio is 1.6, that means you have 1.6 times the risk of disease in the exposed. Or you could say a 60% increase. Increased risk of 60%. What if the risk ratio is 0.5? That means you would have 0.5 or half the risk of the disease in the exposed. So it's very handy for quantifying in simple terms how much risk goes with a certain risk factor. So a couple of ways to calculate it are either, if you don't have the incidence rate, A over A plus B over C plus D, or cumulative incidence of the exposed divided by cumulative incidence in the unexposed. With risk difference, it was incidence in the exposed minus incidence in the unexposed. Here, it's just slightly different. Instead of minus, it's divided by. So make sure you're aware of that. So if we do all that math, it should come out to 400 over 6,000 divided by 100 over 4,000. That will give you a risk ratio of 6.7 divided by 2.5, which is 2.68. So the risk ratio here is 2.68. What that means is that those who have the risk factor, which in this case is being sedentary, those who are sedentary are 2.68 times more likely to develop coronary heart disease than those who are active. Or you could say they're the risk is 268% higher, either way. Alright, here's another example. This is from a cohort study, so remember that's when we follow people over time. Cohort study of hypertension and cardiovascular morbidity and mortality. Morbidity means disease, mortality means death. So this data is from the Nurses' Health Study. Okay, so what you see here is hypertension. Either they have hypertension, that's high blood pressure, or they don't. And then non-fatal heart attack. Did they have a heart attack but not die from it? Okay, yes or no. Okay, so here you don't have incidence rates calculated for you yet. So, remember A over A plus B, so that would be 117 over 117 plus 13,305, and so that number is here, divided by C over C plus D, so 125 over 125 plus this number gives you this number. So if you do all that math, you get 0.00872 divided by 0.00117. That comes out to 7.5. So this can be interpreted as those with the risk factor, which is hypertension. So hypertension increases risk of non-fatal heart attack by 7.5 times. Women in the Nurses' Health Study with hypertension have a 7.5 times higher risk of having a non-fatal heart attack compared to women without hypertension. Okay. There are some situations where where data might show a higher risk ratio, relative risk, but not a higher risk difference. Here's an example of that. Lung cancer and coronary heart disease. Smoking is a risk factor for both of those. Okay, so you're looking at mortality rate as your outcome from these different diseases. So cigarette smokers, 140 people in the study died of lung cancer, and 669 died of coronary heart disease. The non-smokers, 10 died of lung cancer, and 413 died of coronary heart disease. They've already calculated the relative risk for you. So the relative risk of lung cancer is 14.0. So that means smoking increases risk of lung cancer by 14 times. The risk ratio for coronary heart disease is 1.6. So smoking increases the risk of coronary heart disease by 1.6 times. Okay? So, what this means is that smoking is a much stronger risk factor for lung cancer. 14, risk ratio of 14 versus 1.6. But eliminating cigarettes would prevent more deaths from coronary heart disease. We know this because of the risk difference. The risk difference is 130, and here it's shown per 100,000 exposures. That's just a way of quantifying how long people were exposed, or because if they smoked for 1 year versus 50 years, their exposure time is different. But the risk difference is much higher. 256 is higher than 130. So that means that you could save more lives in terms of coronary heart disease if you eliminated smoking. Why is that? How can you have a higher relative risk for lung cancer but a higher risk difference for coronary heart disease? That's really what this is getting at. And the answer really has to do with how common these conditions are. Coronary heart disease is much more commonly occurring than is lung cancer. So even though cigarette smoking increases your risk a lot more for lung cancer, from a public health perspective, it might be better to try to eliminate smoking, because to try to kind of sell it as reducing risk of coronary heart disease, because coronary heart disease is so much more common. So just because you have a high relative risk doesn't mean that the risk difference is higher, and that's why it's important to calculate both. Okay, we've talked about 2 of the 3 measures of association. The third is the odds ratio. It's going to be abbreviated OR, and it compares the likelihood of an event between 2 groups. So it's pretty similar to relative risk, but we'll talk about why it's different. It's calculated A over B divided by C over D, and it's used for case control designs. That's really the difference in the odds ratio versus the relative risk, because the relative risk calculates the likelihood of something happening. In case control studies, something's already happened, so it really doesn't make sense to do it that way. But the interpretation of the odds ratio is the exact same. So an odds ratio of 2 means twice the odds. An odds ratio of 0.4 means 60% lower chance, and so on. So here's the 2x2 table for a case control study. You've seen this in a previous slide, but just remember the cases and controls here on the top, and then you don't have an incidence rate, you have a proportion exposed instead. So here's an example. In kids who take a bath daily versus not every day, what are the odds of developing head lice? So the study would be designed in that they took kids with head lice and kids without head lice, and then asked, do you bathe daily or do you not? And so 12 kids bathe every day but have head lice, 208 bathe every day but don't have head lice, 20 have head lice but do not bathe every day, and 128 do not have head lice and do not bathe every day. So to calculate the odds ratio, A over B divided by C over D. So that's 12 over 208 divided by 20 over 128. You do all that math and you come out with an odds ratio of 0.37. So what this means is that children who bathe every day have a 63% lower risk of head lice than do those who do not bathe every day. When the odds ratio is lower than 1, you don't say it's 37% lower, it's 1 minus the decimal. So 1 minus 0.37 would be 63%. Okay, remember that with relative risks and odd ratios, the calculations are different, but the interpretation is identical. So an odds ratio or a relative risk of 1 means the risk isn't any different between exposed and unexposed. So if we found an odds ratio of 1 for the head lice study, that would mean that it doesn't matter how frequently you bathe in terms of are you going to develop head lice or not. For a relative risk or odds of 2, that means twice the risk, or 200% increased risk. If the odds ratio was 5.72, that would be 5.72 times the risk, or a 572% increased risk. If the relative risk or odds was 0.62, that would be a 38% decreased risk, and so on. Okay, one more concept to talk about as we start to read some journal articles, some research studies with odds ratios or relative risks. You'll often see what's called a confidence interval. This is abbreviated CI. So you may want to actually make a list, some notes of common abbreviations, RR, OR, CI, all of that, because there are quite a few in epidemiology and they can get confusing. This one's a little confusing because cumulative incidence is also abbreviated CI, so you just have to be aware of in what context does it make most sense. Usually you will see relative risks or odds ratios reported with a confidence interval. It might look like this: odds ratio equals 2.4, and then in parentheses some range with the odds. The number of the odds ratio would be somewhere in the middle of that range, so 2.0 to 2.8 in this case. Usually you see these in tables and figures in journal articles and research studies, and it will tell you data is presented as odds ratios, parentheses, confidence intervals, or something like that. So just make sure you read the caption on the figure to make sure that it really is a confidence interval. Usually they're 95% confidence intervals. You can do different percentages, but that's the most common. Basically what it does is it tells us if the observed odds or relative risk is meaningful. So say you had a relative risk or an odds ratio of 1.07. So there's a 7% increased risk of whatever, toe cancer. Well, is that a lot? It can be hard to know. And so the confidence interval helps us to know, is that really a meaningful number? What it does is it gives an estimate of the highest and lowest values that you might calculate for relative risk or odds ratio if the study was repeated 100 times using the same number of participants in your study. So if you did the same study 100 more times using the same number of participants, what range of odds or ratios or relative risks would you find? So in this example, if you would find somewhere between 2.0 and 2.8, 95 of those 100 times. A confidence interval tells us if a relative risk or an odds ratio is statistically different from 1.0. So we know 1.0 means no additional risk. Does 1.01, is there really additional risk? Sometimes even higher numbers, especially if you have a really small sample, maybe you studied 10 people. The confidence interval helps us know if that odds or relative risk does it really mean something. So let's say the odds of developing the flu is 1.3 for those living in dorms compared to those off campus. The confidence interval is 0.9 to 1.7. This means that if you repeated the study 100 times using the same number of participants, 95 of those times you would get an odds somewhere between 0.9 and 1.7. If that confidence interval includes 1, which this one does, 1.0 is between 0.9 and 1.7, that means that 1.3 number that you came up with is not statistically different from 1. From an odds of 1. If the confidence interval includes 1, we would say we calculated an odds of 1.3, but we're not confident that that's actually an increased odds. So we would say there's no increased risk of developing flu for those living in dorms. If the confidence interval includes 1, it's not statistically different from 1.0. Okay. Again, if you're having trouble with any concepts, make sure you read the text. It's very helpful. Discussion number 2 is this week. Also be sure to take quiz number 3. Those are both due Friday by 11:55 p.m. Make sure you read your assigned chapter, and then be aware that I will be posting an article for you to read for Module 4. It's very short, but make sure that you're aware of that. Thank you all.